Alright, hello guys, welcome back to this particular channel. In today's video, I'm going to be looking at chemical bonding. Chemical bonding is a very important concept in chemistry, and without chemical bonding, you cannot even have chemistry, because chemistry is talking about interaction, right? Between two elements. When two elements come together, what happens? So that's why chemical bonding is a very crucial part of chemistry. Now, today we're going to be looking at all these different outlines I've already given on the board this today. So the first one I'm going to be looking at the definition of chemical bonding. So what is chemical bonding? Now, chemical bonding is the interaction between two or more elements, right, to become a compound. So that's just the simplest or the vaguest definition you can give to chemical bonding. So when you have an interaction between two elements, A plus B, that is the atoms of A and that of B, they are coming together to form a compound, let's say AB in this example, right? So this is what we call chemical bonding, and this means that there's either exchange, either somebody is donating an electron, another person is receiving an electron, or they are possibly sharing electrons. All these are the different, ways to look at what happens when chemical bonding happens, right? That is just the simple concept of chemical bonding, right? And now, why should A want to interact with B to form AB? Now, the major reason is basically for this element to be able to obtain a stable electronic configuration, a stable electronic configuration. That is the reason why this A plus B will give you AB. That is why they'll be willing to go into a reaction, right? We've seen some elements that are already stable on their own. They won't be willing to interact with others, not to even talk about forming other compounds, right? And for you to be able to distort those kind of elements to come into a reaction, you're going to be taking a lot of energy. I believe you understand what I'm trying to say. So that is one of the major reasons why chemical bonding is very crucial, and that's what chemical bonding is. Second thing we're going to be talking about today is types of chemical bond. So I'll be looking at the first one, chemical bond. We are going to be looking at the ionic bonding. Ionic bonding is a very crucial bonding that has to do with two elements. So the first element now is donating electron, while the other one is receiving electron. So I'm trying to be as simple as possible. So I want to take you as if you don't know anything in chemistry and just try to break it down for you so that you can understand the concept behind it. So we are talking about one of the elements, A, trying to give out an electron to give out A plus E minus. Is this showing? This showing, okay. And another element, B, trying to receive the electron to give you B minus. I believe you understand what I'm trying to say. So yes. So you understand what I'm trying to say. So in this situation, you are going to be having an interaction between these two compounds, A plus B minus, to give you AB. So it makes it easy for these atoms or these elements to interact together. I believe you understand what I'm saying. So let me give you a very easy example to understand. So I'll be using as much part of this board as possible. So let's give you an example of sodium and chlorine. So sodium and chlorine. Now these two elements will interact together. The basis of interaction is going to be that sodium is going to be releasing an electron to give you Na plus, to release, it's going to be releasing this electron. Now, how is it going to be able to release the electron? I'm going to be showing you in a diagram, right? So the next thing is chlorine is going to also be accepting the electron, right, to give you E minus, to give you Cl minus. So let me explain that to you. What's the electronic configuration for sodium? Sodium is number 11, am I correct? Please confirm that. Chlorine is number, I think 15. Right? So let's draw the atomic structure for sodium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you're going to see that on the outermost shell, sodium is having 1 electron. Am I correct? So now let's draw that of chlorine. Chlorine is number 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, and number what? 15, right? Oh, sorry, chlorine is number 17, sorry, 17, 15, 16, 17, right? 17. Now, given this basis of interaction, you're going to notice that don't forget, when I was defining chemical bonding, I told you that the reason why elements will be ready to interact or willing to interact together is because they want to have a perfect electronic configuration. That is, they want to get that octet configuration, and that's the reason why sodium here, Na, this is sodium, while this is chlorine. Sodium will be willing to lose this outermost electron because it will take less energy for it to lose this outermost electron than for it to add 7 more electrons to this outermost shell. Do you get that? So one of my teachers used to give this illustration, so let me do that illustration here. It will be easier for me to send one person, maybe in this particular place I'm using, one person, to send the person out than to have me bring 7 people into this particular environment. Do you understand? It will take me more convincing to do that. I believe you get that. So it will be easier for sodium to just let go of this one electron and obtain the octet configuration easily. While for chlorine is already having 7 electrons in its outermost shell, and it will be willing to receive 1 electron more than for it to lose more electrons. So in chemical bonding, one of the major things we always consider is energy of that reaction, right? In some of our previous videos, we would have looked at same where we discussed about energy and all those things, and you notice that the energy, the lesser the energy required for a reaction to take place, the easier it will be for the reaction to occur. So in this situation between interaction with sodium and chlorine, to be easier for sodium to release one of these electrons and chlorine to receive that electron for the reaction to take place. That's how you'll be having this sodium losing one of these electrons. This electron is going out, right? Going out, let me bring it here, and coming into this particular portion. So this is what we mean by ionic bonding. So one of the elements is ready to release to the other element, right? So that's been established, and I believe you understand. I've given a perfect example. I'm not going to spend too much time on the other ones. Now, for the covalent bonding, one of the things you must take note is, so in covalent bonding, you have a situation whereby those elements are willing to share. Unlike here, one is donating and releasing it to give to the other. While in this case, now there will be sharing of those electrons so that both elements can obtain the octet configuration. So let me use the perfect example here. The perfect example I'll be using for covalent bonding is going to be, let's use ammonia. Ammonia is number 7, right? Ammonia, let me get the electronic configuration for ammonia: 7, 4, 5, 6, and 7, right? And why hydrogen is that is for nitrogen. Is it showing on the board? Okay. Hydrogen is going to be just 1 electron, right? So in this particular example, you're going to take note that the interaction between sodium and ammonia requires 3 hydrogens, right? 3 hydrogens. So it means that, let me put the 3 hydrogens here, like this and like this. Let me just put it that way, right? So 3 hydrogens. Now look at the situation of nitrogen. Nitrogen will need how many electrons to become stable? 3 electrons. Am I correct? So that means you need 1 more here, I need 2 more here to obtain that octet configuration. Do you get that? So doing that consideration, we are going to see that this hydrogen also needs an electron also. This one needs 1 more electron, this one needs 1 more electron, and this one needs 1 more electron to become stable. So what do they have to do? They have to share. For instance, you want to eat bread and beans, for instance. Maybe that's your favorite food, right? And you only have bread, someone has beans, and the other person too has beans but needs to eat bread. What do? You share. You give the other person part of your bread, and you give the other person gives you part of his beans. So it's just as simple as that. That's what happens in covalent bonding. Simple interaction. So let's do that. Let me break down the reaction for nitrogen again. 1, 2. I'm going to see what's going to happen. 1, 2, 3, 4, 5. How many do you have now? 1, 2, 3, 4, 5. Okay, good. Now, so that means one of these nitrogen will come here and interact with this one to bound with this. The second hydrogen will come here and interact with this one to bound with this. So this is the sharing that we're talking about, together to bound with this. Do you understand what I'm saying? So there has been an interaction between the nitrogen and the hydrogen atom to form ammonia, NH3. So there are other different examples like in water and other examples, right? So now metallic bond, this is a bond found in metals where the valence electrons are the electron in the outermost shell, right? Valence electrons are delocalized, and when they are delocalized, they are now moving around in that particular orbital to form a strong bond. Just like you have in sodium here, for instance, you can see that this electron now can be delocalized and form a strong bond between all the atoms that are making up that particular metal, right? So the next one we're going to be talking about, okay, we've covered metallic bonding. Talk about the polar and non-polar covalent bonds. Now, we already know what covalent bond is basically. That's really the sharing of electrons. While for polar covalent bond talks about unequal sharing of electrons. So there's sharing of electrons going on, but the electrons are unequally shared. While you have an example of HCl, for instance, the sharing of electrons going on, but it's done unequally, right? So somebody is donating more into this particular situation than the other, right? While for non-polar, you're having equal sharing of electrons. So both of them are sharing those electrons equally. I don't know if you get what I'm trying to say. So there's an equal or balanced sharing of electrons, just like you have in the situation of chlorine, right? So the last bond we are going to be talking about is the coordinate dative bond. Coordinate dative bond is a bit of a complex bond, and I'll proceed with this. It has to do with the interaction between ammonia and hydrogen, for instance, right? You can see this is ammonium ion, right? Ammonia. So like if you have ammonia and you're trying to add one more hydrogen to it, right? One more hydrogen to it, and for that to take place, that means there has to be a kind of a dative coordinated bond taking place. We have these ammonia and nitrogen. You're going to notice that this is already shared. These electrons are shared with all the hydrogen atoms, 3 hydrogen atoms. This is H, this is H, and this is H. But you can see that these electrons are already established. They are paired electrons, and these electrons are known to be called lone pair electrons. Lone pair. That means they are standing alone. Now, in the coordinate dative bond, what happens is that instead of one electron to be shared with another from another atom, for them to share these 2 electrons to become more stable, in the dative coordinate covalent bond, what happens is that this lone pair of electrons is rather shared. So one element is bringing out or bringing forth the electrons needed. I don't know if what I've said is clear. So this electron, this lone pair of electrons is rather shared instead of it bringing one and this one bringing one. Do you get what I'm trying to say? So these electrons are shared. So at the end of the day, we are going to be having something that looks like this: 1, 2, 1, 2, 1, 1, 2, 1. Oh, sorry. Am I doing this right? 1, 1, 2, 1, 1, 2, 1, and then you'll be having a positive charge around here. That's why you see that you cannot write ammonium without having a charge on that particular part. Do you understand what I'm saying? So it's as simple as possible. And then let me finalize by talking about Lewis-Dot structure. There will be another video that will be breaking down Lewis-Dot structure properly. But the Lewis-Dot structure helps you to be able to understand chemical bonding. And let me just give you some of the few basics. Some of the few basics include that. So let's say for water, for instance, H2O. Let's draw the Lewis structure for this. This is oxygen is number 8. So let's do oxygen 1, 2, 1, 2, 1, 2, 1, 2. So having hydrogen here, hydrogen here. So every bond, this is the bond between hydrogen and oxygen, and this bond is made up of 2 electrons. So that means this is having 2 lone pairs. Do you get the concept? So maybe in the subsequent videos, I'm breaking out how we got this particular structure. So let me do for ammonia as well. Ammonia is NH3, right? So you'll be having NH, H as well, and then you are going to be having the lone pair of electron. In fact, this is the way we used to do it. Lone pair of electron hanging somewhere around there. So I'll be giving you a breakdown proper calculation in the next video you're going to be seeing in this slide. My name is Ezekiel. Welcome to Charisnova Educational Consult. I'll be seeing you in the next video. Thank you.